Hello, good morning, students. Today I'll just brief you about the projection of planes. I have already sent the notes to you and also the step-by-step procedure. Uh, this plane, this is a plane, okay, and it is also called as a lamina. It has length and breadth, but the thickness is negligible. So you can see the thickness. It is negligible. It appears as a line. Okay, so this is called as a lamina, and the shape of the lamina is a equilateral triangle. Okay, it is an equilateral triangle. So this is called as the edge or side of the lamina. Okay, so a triangle has three edges, and this is called as the corner, the point at which the two edges meet, that is the corner. So a triangular lamina has three corners and three edges. Okay, so this is an equilateral triangular lamina. Similarly, you have a square lamina here. Okay, this is a square lamina. You can see it has four sides or edges and four corners. These are the corners, the point at which the two edges meet, and that is the corner. Now you have a pentagonal lamina similarly, where it has five sides. As you know, the pentagon has five sides. Okay, a regular pentagon means it will have all sides equal and all angles equal. Okay, so a pentagonal lamina has five sides and five corners. Okay, so we'll start with the triangular lamina here now. So this triangular lamina can rest on the horizontal plane. Suppose you consider this white sheet to be the horizontal plane. So the lamina can rest on the horizontal plane on one of its edges like this. Okay, so it can rest on one of its edges, or it can rest on one of its corners. Okay, so in that case, what happens if the lamina is resting on its edge? Okay, the surface may be inclined to HP. Okay, if you consider this to be the HP, so the lamina may be inclined to, surface of the lamina may be inclined to HP. Okay, so if you consider the vertical plane also like this, now you can see this is the horizontal plane and this is the vertical plane. So okay, so the lamina is resting on HP like this, the surface is inclined to HP, and the lamina now it is also inclined to VP. Okay, so if I make it like this, the lamina also becomes inclined to VP. So whatever problems you get on projection of lamina, so you will be getting 3 points. One is what? The lamina is resting on HP, okay, on one of its sides or edges. That is one point. And second point will be the HP condition. What will be the HP condition? The surface of the lamina is inclined to HP at some angle. Okay, that is theta. That will be given in the problem. And he'll say the surface is inclined to HP, and then the third point will be in the problem. The third point in the problem will be the edge on which it is resting on HP. So this edge which is resting on HP is inclined to VP. So this is the vertical plane. So if I keep the lamina like this, the edge will be inclined to VP. Okay, so these three conditions will be given to you in the problem, and you will be asked to draw the projections of the lamina. Okay, so I have given you the step-by-step procedure for a triangular equilateral triangular lamina resting on edge on HP. Okay, so now I'll tell you what how it has to be done. Okay, so this lamina, this is a triangular lamina. So the initial position, you have to assume that the lamina is completely resting on HP like this. Okay, it is completely resting on HP. So this is the horizontal plane and this is the vertical plane. It is standing vertically, therefore it is called as the vertical plane. So you have to imagine the lamina to be completely resting on HP such that the edge, suppose I name the edges as A, B and C. So these are the three corners. So AC is the edge. Are you able to see this? AC is the edge on which the lamina rests on HP. So you have to draw the initial position, that is the first position of the lamina, such that this edge is perpendicular to VP. So this is the vertical plane. So this edge will be perpendicular to VP and you have to assume that the lamina is completely resting on HP. So in this position, it is very easy to draw the top view. So in the top view, what you see the equilateral triangular lamina. You see the equilateral triangular lamina in the top view. So in the front view, if you look from here, so this is the front view. When you are viewing from here, it will appear as a line. You will see this edge. So this edge, I told you, it will appear as a line because the lamina is of negligible thickness. So if you look from the front, when the lamina is like this on HP, if you look from the front, you will see a line. The line will be on the XY line. The lamina appears to be on the XY line like this. If you draw the projectors from here, they will be on the XY line. This is the XY line, which is the line of intersection of HP and VP. So this is the XY line. Okay, so what happens? This will be the front view of the lamina and this will be the top view of the lamina. So when you open the horizontal plane by 90 degrees, as I said, when you open the horizontal plane by 90 degrees, okay, so this is the initial position. When you open the horizontal plane by 90 degrees, the triangle will go below the XY line. Okay, the triangle will go below the XY line. You can see this is the XY line. It will be below the XY line, and the triangle in the top view, the triangular lamina appears as an equilateral triangle, same, okay, of same length. So this is A, B and C, and in the front view it appears as a line on the XY line. So this will be the front view of the lamina. So a line on the XY line. So this will be, if you look from here, the corner A is visible to you and corner B is visible to you. So you can write it as A dash and B dash. So this is the front view of A and corner A and B. And C is invisible, so it is behind A. So this will be C dash. Okay, so this will be the initial position of a triangular lamina which is resting on HP on its edge, one of its edge. Okay, have you understood this much? So the initial position is very important. Suppose if it is a square lamina, then it will be like this. The edge, if suppose this is the edge on which it is resting on HP, it should be to your left. The edge should be to your left. Okay, and the edge must be perpendicular to VP. Okay, it must always be perpendicular to VP. So in the initial position, you have to imagine the square lamina to be completely resting on HP. Okay, the edge on which it is resting on HP must be perpendicular to VP. Okay, now If it is in this position, again you will see in the top view you will see a square, okay, and in the front view you will see a line on the XY line. The front view will be a line on the XY line for the square lamina. So if it is a pentagonal lamina, again I will remove this. See, if this is the edge on which it is resting on HP, this is the edge on which it is resting on HP. So this edge must be perpendicular to VP. Okay, you have to imagine the lamina to be completely resting on HP. In this position, you have to draw the initial position, that is top view and front view. So in the top view, you will see the pentagon, regular pentagon, and in the front view, you will see a line on the front view will be a line on the XY line. Okay. So if it is a hexagonal lamina, again the edge on which it is resting should be perpendicular to the VP. Okay, so if it is a hexagonal lamina, regular hexagonal lamina, you have to draw the top view like this. This is the edge on which it is resting on HP. It should be to your left. Okay, and the front view will be a line on XY line. Okay, so this is with this knowledge I have given you the initial positions, okay, of all the laminas when they are resting on one of the edges on HP. Okay, please go through the notes, you will understand. Next, we will solve the problem now. I have opened the HP, okay, by 90 degrees. So this becomes my XY line. Okay, the problem is a triangular lamina is resting on HP, okay, on one of its sides, and the surface is inclined to HP. The surface is inclined to HP, and the edge on which it is resting on HP is inclined to VP. So now it is inclined to VP. You can see if this is the vertical plane, it is inclined to VP. Okay, so this will be given in the problem. So I told you the three positions of the lamina will be given to you in the problem. So what you have to do, first you imagine the lamina to be completely resting on HP like this. Okay, now we'll consider ESC. Okay, you imagine the lamina to be completely resting on HP. Then you make the edge on which it is resting on HP perpendicular to VP like this. Okay, so this AC is the edge on which the lamina is resting on HP. Okay, so when you draw the top view, you will get the triangle, equilateral triangle, okay, with one of the sides perpendicular to VP or perpendicular to the XY line. Okay, then I'll just draw this. You use the scale, you draw it to scale. I'll draw it in freehand. So this is the edge on which it is resting on HP. Okay, and this is the equilateral triangular lamina. Okay, you use the scale and drawing instruments to draw the projection. Okay, so this will be A, B and C. Now this is the top view. Okay, this is the top view. What will be the front view? When the lamina is completely resting on HP, the front view will be a line on the XY line. So draw the projectors from C. A and C are in the same straight line. So, okay, so draw the projectors from C and projector from B up to the XY line and draw the line there. So this will be the front view of the lamina which is completely resting on HP. So what is this? This corner is visible to you, A and B, B dash. So top view will be A, B and C. Front view will be A dash, B dash and C dash. So C is behind A. If you look from here, this is the front view. C is behind A. Therefore C will be hidden. Okay, so this is the initial position of the lamina which is resting on HP on one of the sides or edges. Okay, next is in the problem you will be given the HP condition and VP condition. So what is the HP condition? The surface is inclined to HP. So the lamina is like this and it is resting on the edge AC. If he says the surface is inclined to HP, you have to lift the lamina like this. Okay, when you lift the lamina like this, you can see this edge is always on HP. AC, the edge AC will always be on HP. When you lift the lamina like this, the front view, what happens to the front view? It will be lifted. Okay, so here the front view will be lifted. B dash will go up above the, it comes above the XY line. You see, it is now B dash will be on the HP on the XY line now in the front view. So if you lift this, B dash will be above the XY line. If this is VP, it goes above the XY line. So but A dash and C dash will always remain on the XY line because the lamina is resting on HP on one of the sides, that is A dash and B dash, C dash. Okay. Now from here draw a line inclined to HP. Suppose the inclination is say 45 degrees. So theta is 45 degrees. Then what happens? Draw a line inclined at 45 degrees to the XY line. Draw a line inclined at 45 degrees to the XY line. So this is 45 degrees. Okay, and what must be the length? The length of this line should be equal to the length of the previous front view. So that is A dash and B dash. So measure A dash and B dash. From here you measure from A dash to B dash. So this length and this length must be same, B dash. So this will be the HP condition. For this you have drawn the front view, so you have to project the top view. So projecting the top view, just draw the projector from here, A dash and C dash, vertical projector. From the previous top view, draw a horizontal projector like this. The point at which they meet, that will be the new point A, and from C draw a horizontal projector. This will be the new point C. Next B, draw the projector, vertical projector from B, and from the previous top view draw a horizontal projector. This will be B. So join A, B and C. This will be the new top view. Okay, you can see initial position the lamina is bigger. Second position, because it is inclined to HP, if you look from the top, okay, if you look from the top, the size of the lamina has reduced, but this line, this edge will be same. You can see this AC and this AC are same, only AB and BC will change. Okay, if it is like this. So this is called as the HP condition. HP condition. This is called as the initial position. Okay, next what? VP condition. He will say that the edge on which it is resting on HP is inclined to VP. Now this is the edge which is resting on HP. AC is the edge which is resting on HP. You can see here AC is the edge which is resting on HP. Okay, now it is perpendicular to VP. This is the vertical plane, correct? So this is perpendicular to VP. So now what? The edge is inclined to VP. The edge on which it is resting on HP is inclined to VP. Now it is perpendicular, so make it inclined. Either you turn it like this or you can turn it like this. Okay, so if you turn it like this, how to draw the third set of views, that is VP condition. Suppose the edge is inclined to VP at 30 degrees. Suppose he says the edge on which it is resting, that is AC, is inclined to VP at 30 degrees. Then draw a line from XY line which is inclined to XY line at 30 degrees. So this is the true inclination. Now what? Now you take this AC, this edge on this line. Take the edge AC on this line. This is A and this is C. Let this be A and C. Then draw this top view, second top view in this position. How to do that? With A as center, measure, take AB as radius from this figure, with AB as center, okay, with AB as radius, with A as center, come here and draw an arc. Okay, so this AB and BC are same. Okay, so measure this length AB with your compass. Then with A as center, from here with A as center, draw an arc. With C as center, cut that arc. The point at which the arcs intersect, that will be the point B. Join BC and BA, DAC. So this will be the VP condition. This will be the VP condition. Now you have to draw, you have the top view which fulfills the VP condition. To draw the front view, just draw the projectors from A, B and C. You will get the front view. So from A, draw the vertical projector. A is on the XY line, so the vertical projector should be drawn only up to the XY line. So this will be A dash, third set of views. B is above the XY line, so draw the vertical projector from B, and from the previous front view B dash, from previous B dash, draw a horizontal projector. The point at which it cuts, that will be B dash. Then C, again C is on the XY line, so draw the vertical projector from C to cut the XY line. The point at which it cuts, that will be C dash. Now join A dash, B dash, A dash, B dash, B dash and C dash, and C dash and A dash. This will complete the projection of the triangular lamina, okay, which is resting on its edge on HP. Surface is inclined to HP at 45 degrees, and the edge on which it is resting on HP is inclined to VP at 30 degrees. I think this is the problem which I have given you the step-by-step procedure. Okay, so the same type of problems I have given for square lamina in my notes. You can see the notes from problem 1, 2, 3, 4, 5, 6 and 8. Okay, I have missed out one number there, 7. Okay, so it is a printing mistake. So in the notes which I have sent you, it is problem number 8. Okay, so those problems you will be easily able to solve. The initial position is, if it is a triangular lamina, when it is resting on its edge on HP, the edge on which it is resting on HP must be perpendicular to VP. Okay, so this is the VP, this is the vertical plane, so it must be perpendicular to the vertical plane. Okay, similarly for a square lamina. Okay, similarly for a pentagonal lamina, and you have to imagine or assume that the lamina is completely resting on HP. So in that position you have to draw the initial position. I hope you will be able to understand this if you follow the procedure which I have sent, and read the problems, understand the problems in the notes, and try to solve the problems on your own. Okay, so you give me feedback whether you have understood what I have taught you on this video. Okay, so that I can make more videos like this and send to you. Thank you.